Hi everyone. I hope everyone is doing well. So today I think we'll discuss on a very specific system design topic called as Proxy SQL. Um I think I got few requests wherein folks had requested that they wanted to understand the type of load balancers that are used on relational databases. So Proxy SQL is actually related to that. I'll also, before we get into the details, will like to start the discussion by sharing, like, I think a real, incident where Proxy SQL, really helped the organization. Uh, I think in my past experience, basically, I have seen use cases wherein relational databases, for example, have been set up, and then as the number of users that keep on increasing over a period of time, the number of times the outages actually happen also start to increase. And that is primarily because a very poor planning has been done on not understanding the scalability as far as the number of users that are coming in. And also, it's not a very good practice to just allow the databases to run without, like, I would say, guardrails in place, right? So Proxy SQL is essentially some sort of a guardrail which doesn't impact the end user, which is, you've got your customer, or your applications, right? Without failure, right? So jumping right into the definitions, and what we are going to cover is uh, what are Proxy SQL used for, what is the what are the some challenges that it helps to overcome, and one real example, as I do always with most of my system design topics, and then finally some detailed technical terms so that you could stand out in the product management interview round, helping on that aspect. Knowing these terms actually also is important for your conversations with your DB engineers, right? Essentially, proxy SQLs are used to load balance traffic among your multiple servers hosting the MySQL databases, right? It's an open source and it is compatible with variety of relational databases, like, for example, Amazon AWS Aurora, Amazon Relational Database, RDS, Oracle MySQL, right? It allows for sharding across multiple servers. You would be surprised that most of the times companies actually invest. This is probably the least, I would say, sought out design challenge that they actually try to address, and it's also one of the most frequently, I would say, frequent reasons to actually cause a lot of, I think, database outages, right? So you don't want to, like, wait till the end where you have, like, scaled enough, and then invest in setting up Proxy SQL. Also, it helps to improve the availability by switching over, to the standby nodes. The standby nodes are nothing but, like, your master slave replicas, that you are, going to run in case one or more of your master server, fails, right? Looking at the structure on how you can actually think of Proxy SQL is, there'll be a lot of front end apps that are requesting data directly from the database. One way is that you don't put a Proxy SQL, which is this guy here, and you just allow the writes and reads directly from your slaves, right? So, which puts enormous load on your databases, right? Not a good system design practice, right? So, what you can do is insert Proxy SQL with some configurations on, for example, what would be your master nodes, what are the slave nodes, what are some of the orchestration policies, how many times, for example, do you, like, allow for master nodes and slave nodes to fall back, right? Obviously there is a good amount of version releases that happen on Proxy SQL, so make sure that, I think, your RDBs and Proxy SQL versions are compatible. So looking at one of the quick real use cases on this is that, let's say, for example, you're trying to understand, or, like, trying to set up a ride sharing app, right? And that is using your traditional databases, for fetching user information, right? So let's say you're looking at the customer name, the right start point by, you could have longitude and latitude both, right? And then right endpoint, right? There are some mathematical formulas that calculate the approximate fare that you're trying to fetch that, and the approximate time for it based on the kilometers and maybe the real time information of the speed of the vehicle. You have calculated that, and then you have it in your database. Now imagine hundreds of users are actually requesting on a busy, let's say, station, right? They're requesting this information, right? So they probably will give you this information. Customer name is basically some sort of an identifier, right? You get a right start point and right end point. What is going to be fetched is the approximate fare and the approximate time for ride, right? So in this case, basically, you are doing a lot of data pull from your SQL servers, wherein similar customers from the past, for example, might have done similar rides, and you're just trying to showcase the fares and the time, right? So imagine this is a peak hour, uh, office going time, right, or a football match or whatever it is, right? There are a lot of requests that are coming in to your databases, right? Database servers. Now, in case where you don't have a proxy SQL, it can really overwhelm your master database and slaves, right? So as a I would say a really good system design practice, it would be useful to load balance this and distribute the traffic, let's say based on approximate time for rides or fares or whatever it is, right? Or not even related to the customer characteristics, right? I mean, when we covered load balancers, right, we looked at ways in which you can distribute, that you can perhaps use some sort of a hashing algorithm to distribute the traffic. That's not the point. The important point is that you need to have some sort of load balancing capability, right, in between, where the queries that you are the queries that are requesting the data don't end up directly hitting the same server multiple number of times, overwhelming the system, right? So that's, I think, one of the frequent use cases. You can probably think of another case where you had a food delivery app, and uh, you know office going time, or right before that there's a jump in the surge of queries, right? So those times, proxy SQL can like really help keeping the system stable, and also the availability, right? uh, uh, Usually, I think two terms that I would call out, like for example, that are important to understand are orchestration. They're usually Orchestration is basically, it's a monitoring tool that helps to understand the servers and the load on the servers, and then basically it will perform an automatic kind of a switch whenever it is required, right? So for example, once you set up, let's say, the topology that you have this master node and you have three slave nodes, right? In this example, this is how you're just set up your monitoring. Now, as and when you obviously scale, right? Let's say you put in more master nodes, right? Or you put in, let's say, more slaves, right? You'll have to obviously uh, change the topology, and then the orchestrator will help you facilitate that, right? uh, I think there's one more important concept related to flapping. Essentially, what happens is that uh, orchestrator role is to essentially find out if this master database has failed. Then it will try to have a backup wherein the slave is actually, which is maybe an exact replica from 1 hour back or 2 hour back. It will make that slave as the master node. It will switch to that until the master node has recovered, right, and switch back only once there's confirmation of master node recovery, right? uh, this can be done only, let's say, a fixed number of times, because if I allow this, for example, if I say that allow on every master fail, then you can imagine what will happen. The first time, I think it will work well because this is your master node. Slave is, let's say, this one. Then this slave one, for example, has been made a new master, and these two slaves are actually now treating this slave one as the master node, right? Now imagine this one also goes down along with your original master database that has gone down. Now you'll have only this slave 2 as your master slave, and then your slave 3 as your slave node, right? Imagine now this is also gone down, right? So you're just left with one master. There is no slave basically left now, right? So what you are essentially doing in each step is when you are creating a master slave topology, right? You are flapping. You are saying that I am allowing for the master node to recover, and until it recovers, I am making the slave as a master. You can allow it only finite number of times, if because if you allow it for too higher number of times, then that basically results and I would say listing to some sort of a system crash, right? So you don't want to basically allow that. So I hope this was useful. Feel free to leave comments. This was a very short, like I would say, concept wherein relational databases. If you see, for example, you are using relational databases in your system design, you can also talk about Proxy SQL to do a load balancing. So I hope this makes way into your system design interviews. And until next time, please don't forget to subscribe to my channel. And for more content, please be on the lookout. Thanks and bye for now.